Hello guys, so this is our lab for a double sampling plan. So we're still doing acceptance sampling, I'm continuing, and now we're doing a double sampling plan, right? So like a double sampling plan, right, it works in such a manner that I said last time, if you still remember from our video, let's say a company might have an acceptance number of 2 maybe, right? But their rejection number is 4. So if they find three defectives, it doesn't mean they should reject their lot, right? They might be risking, they might be risking, how can I put this? They might be risking like sending back a good lot to a supplier, or the supplier like might lose, like because there's transportation costs involved with taking the lot back. So they move to what maybe is called a tightened inspection, where they take another sample and then they perform the acceptance procedure again, right? So similarly to, let's say, just write these values, right? So let's say our lot size now, say this is the number of products that are coming in, right? Which is our big N, right? So we have a lot size of 9,000, right? And then we have, from that lot, they take a sample, the first sample, N1, it's small letter N1, right? So, okay. So they take a sample of 150, right? And then their acceptance number is 1, right? Which means they're only gonna take they're only gonna take the they're only going to accept the product if they find one or less defective, which means if they find exactly one defective or zero defective, which translates to one or less, probability of one or less, right? And then the rejection number for the first sample, it's 1, right? So you can see this leaves like a space of some of the aspects being inconclusive, because like the acceptance number is 1, right? But but they reject the lot when they found four more at the on the if they find 4 more on the second sample, not on the second sample, right? So yeah, they reject the lot if they found exactly 4 or more defective products in that lot. Otherwise, if they find maybe 2 or 3, that's when they move to tighten inspection, which means they're gonna move to a double sampling plan initially, right? So if they move to a double sampling plan, they're gonna take a sample, let's say, so these are values that are given, right? Or they are determined like depending on how like the company determines them, right? And then from that sample, the acceptance number now, so that like it accounts for the defective, the acceptance number for the second sampling, it increases to 5, like maybe, and then the rejection number is now, sorry, so our rejection number is now R6, which means that R2 now it's 6, right? So now if they move to a single sampling plan, they only will reject the lot if they find 6 defectives, right? Six or more defective, but they're gonna, like, so like this, what happens here, it affects what happened here, right? So let's say if they found here the acceptance number is 1, let's say they found 2 defectives, right? For them to accept the lot, since their C is 5, right, they have to make sure that they find exactly 5. Like let's say if they found 2 defectives here, as you can see, that exit the accepted. Now for them to accept the lot, they need to find 3 defectives in the second one, which will equate to the C2 of the C2 of the double sampling plan, right? So let's get started, right? So yeah, so now, okay, sorry about that. So now, similarly to a a single plan, right, we have to initially assume process qualities, right, which is the expected defectives that we can find, right? Let me just extend this to here, okay? I just want to, okay, yeah. So now we have to put in our assumed process quantities. So this is the expected proportion non-conforming that they can find in a sample, right? So it's given by PO, proportion non-conforming, right? So it might be zero, it might be, so like maybe like let's say in a test I'll give you to like your assumption up until what value, right? 0 0.01, 0 0.02, and then 0 0.03, right? And then after here, I think you just select the thing and then you drag, let's say up to 0 0.10, right? Like this, right? So now, after you are done, you calculate the, so this is the probability of non-conforming, like in the sample, right? And then now you calculate the percentage of non-conforming, which is 100 PO, right? So you say 100 PO, right? So we say this is equals to this. So it's since I'm calculating a percentage out of 100, so you multiply the probability by 100, right? And then now you drag your formula, right? So now after you are done with that, right? So now since you have two sample sizes, right, you have to put that into consideration, right? So we're gonna write both of them here. So just here on the top column, I'm just gonna write sample sizes, right? So now we have our sample size for the first plan, right? And then we have a sample size for the second plan, right? So for the first plan, we can just say this. So this is our sample for the first plan, which is n1. So we can say this equals to, and then you freeze, sorry, select this, right? And then now you freeze this, cell, right? So we just put dollar sign like this, right? And then now you can drag, right? So since now this cell is frozen, right? So the reason why I like doing it like this, right? So now your formula can adjust like two changes, right? You just have to, let's say if your sample size now it's 200, right? You can just put 200 here, right? And then the entire cell transforms, right? So yeah, I think like it makes it easier for you to do analysis like this. So let's say if you were to change sample sizes and whatnot, it would be easier for you to change because you only change in one place. You don't have to drag and drop anywhere, right? So now you go to, you calculate your N2, right? So your N2 is your sample size for the second plan, right? So you just say this equals to N2 that you wrote, and then also, so N2, and then you freeze the cell as well, right? So similar reasons to why you freeze N1, right? And then now you drag, right? So after you are done calculating your sample sizes, right? If you still remember, in the last video, I said the Poisson distribution is the most accurate. It's the most accurate. It's the most accurate metric, like to calculate your probability of acceptance, right? And for according to Poisson distribution, right? So can I this? Okay, so mm, so okay, I'm trying to. Okay, so my Word document is not opening, so we'll continue. But like you can go and refer back when you analyze the Poisson distribution value, right? So let's calculate what we call the NPO, right? Which is the average number of events, right? So, and the average number of events is given by you multiply your, it's called like, so for the sample is going to be N1 PO, right? So now, since this is your proportion non-conforming, right? Your NPO, it's the, like, it's if like if they find 0% non-conforming in your sample, right? Like how, what's the probability, like what's the proportion of that in the sample, right? And then if they find 1% defective, what's the proportion of that? So like it's like they're trying to determine like, it's if there's 1% defective, right, which is your PO here, and like what's the actual number of that, like in real translation, right, or in actual translation. So it's that proportion, right? So we calculate it by multiplying this by for the first, this for the first sample size, right? And then now you drag, right? And then now you also calculate your NPO for the second sampling plan, right? Which is NPO, right? So, and then you say this is equals to PO multiplied by the first sample size, right? You equate and then you drag, right? So now after you are done with that, right? So now you can calculate your probability of acceptance for the first sampling plan, right? So I'll name the two because we'll have calculate a lot of probability of acceptance since there's a double sampling plan, right? I'll just name the probability of acceptance for a double sampling plan as PA underscore 0, right? So now I'll call this the percentage or probability, sorry, yeah, probability of acceptance for the double sampling plan, right? And then just to save time, right, this is gonna be a percentage of acceptance for the, no, sorry, this is for the single sampling plan, right? Since we're still dealing with the single sampling plan, right? For the single sampling plan, it's going to be a percentage of acceptance for the single sampling plan as well. Right. So now calculate, as I said, like the Poisson distribution, right? It's the most accurate metric, right? Or calculate probability distribution. Yeah, it's the most accurate probability distribution, right? That can be used to calculate the probability of acceptance in acceptance sampling, right? So as such, we're gonna use the Poisson distribution. So it's given by equals to points this, right? So this is the one right here. So you select on it, right? So now your x is gonna be given by your, so you have your x, you have your mean, right? So now your x is gonna be given by, since like your for the first sampling plan, right? So this for, can I put this? So now, yeah. So your x is gonna be your your main value forecast, right? Or your acceptance number. I can say it's gonna be given by your acceptance number, right? So you're gonna put it as the acceptance number, right? And then so that it's consistent throughout, right? Throughout the different proportion defects, right? You wanna phrase this cell here, right? And then semicolon, and then now your mean is gonna be given by your NPO one, right? Which is the average number of events, like in that, assuming that they find different proportion defectives, right? And then your your cumulative, right? It's gonna be given by true, right? Since we're looking for not the probability at exactly one, right? At exactly x, right? We're looking for the probability, right? At x or less, right? Which is gonna say now equals to, right? And then now you're gonna drag our formula. Sorry. Right. And then now we're going to calculate our percentage of acceptance. It's going to be 100 PA. Which is going to be equals to this multiplied by 100. Right. And then now we drag our formula. Right. And then now, as you can see, like from here, right, as the number of defectives, like it increases, right, the percentage of acceptance like decreases, right, to such an extent where it would be impossible for a company like to even accept this. The percentage of acceptance is 0.00019, which that's a very low percentage of acceptance, right? So now, and then now, since you are done with the percentage of acceptance now, so now let's say if you look at this, right? So since their C value is 1, right? Their So it corresponds to this. So the percentage of acceptance, like now, it's 55%, right? 55.7, which is like relatively low, right? Those are very low chances of acceptance, right? And then let's say if they found three or more, right? Now let's say if they find three defectives or four defectives, like in that sample, right? As you can see, like the chances of acceptance, they go, like they keep going low. So now if they find two defectives, the chance of acceptance is 19%. And then if they find three defectives, right? So here and here, the chance of acceptance like goes even more low, like 6%, right? So now to ensure that like this doesn't necessarily mean that the lot is bad, right? So they might have just found three, right? But if they follow the probability, right? The probability, like if even for you, right? If you're doing analysis and you found that the if you found three defects, the probability of acceptance is 6%, right? Like would reject that lot without question, right? So, but now what companies do is that they now move to a more tightened inspection where they take a sample again, and then they would they would do analysis on it to determine now the combined probability of acceptance from both of the sampling plans, right? So now, as you can see, so now this is the data for the double sampling plan, right? So this time they're gonna take a sample of 500, right? And then the acceptance number is 5%, right? It's five. It's five. Sorry, which means like they only accept the lot if they find five or less defectives, right? But now we have to now put like that five. It has to now consider like even the single sampling plan, right? So now let's say if you look at this, right? So if now they find, let's start here. If they find like one or less right here, they'll accept the lot, no question, right? And then if they find four or more, according to a rejection number, the lot is rejected. But as you can see, like there's these ones here, right? If they find two or three, that is when they move to the double plan, right? But now I want you to like pay close attention to this, right? So I'm just gonna expand here, right, for more explanation, right? Okay, let me just reduce this, right? So yeah, I want you to put this into consideration. So now the probability of acceptance is gonna be given as probability of 5 or less in the double sampling plan, right? But then now, as I said, you have to put two samplings into consideration. And so the only time they could move to a sampling plan is if their results are inconclusive. Let's say if they found, as I said, from here to here, according to their C value, this is complete rejection. And then from here to here, they accept, but from between 2 and 3, it's a bit inconclusive, right? So now the probability, like factoring in both of the sampling plans, right? The probability of them, right? So of them finding 5, you have to put this into consideration. So like initially, like in the first sampling plan, so these are two different scenarios, right? So now the probability of 5 or less is going to be given by if like they find on the first sampling plan. So if they find probability of 2, right, in the first sampling plan, right, the probability of 2, and then in the second sampling plan they find probability of 3, they find 3 or less defectives. So I'm just going to say, to indicate this is the first, I'm just going to put _1 here. And then in the second sampling plan, they find 3 or less defectives, right? Plus, the same chances that in the first sampling, they might find 3 defective products, right? Which means you might find it's going to be P of 3 in the first sample, right? And then in the second sample, they find P2 or less, right? So this is the scenario in which like they can find exactly 5 defective, right? It's if in the first sample they found 2 defective products, right? In the second sampling, they have to find 3 or less defectives. Or the second scenario is that if in the second sampling they found 3 defectives, in the second sample they have to find 2 or less defective, right? Which will result in 5 or less defectives, right? So now when doing a double sampling plan, you have to calculate for both, right? So now, since this is consuming our space, right? So now I'll write this here, right? So I hope you understood this, right? So now you have to calculate the probability of acceptance, not probability of acceptance, right? So for this is gonna be your first sample, right? So you're gonna say this is your first sample, right? So now let's say this is your probability if they find in your first sampling plane, so probability that they find two defective, right? So probability of 2, right? And then, or let's say x is equals to 2, right? Just to make it, probability of x is equals to 2. So this is the probability that they find two defectives in the first sampling, right? And then here in the second sampling, if they found 2, right? In the second sampling, they have to find 3 or less. They have to find 3 or less, right? So now, and then the second scenario, so let me just clear this so I can see proper. Again, like the second chance, right, for this to happen, right, it's if now they find in the first sample, they find, so in the first sample, they find, okay, so let me just fix this. It's if they find now 3 defectives, right, in the first sample. So P x equals to 3, right? And then in the second sample, they find probability of x is equals to 2 or less, right? And then now you have to calculate these probabilities, right? So that you can get your percentage of acceptance for the double sampling plan, right? And then now for that, right? So now if you calculate your first probability of acceptance, right? So now initially you do it by, so now in the first sampling, since you know what your x is, right? So you're gonna say equals to Poison test, right? So now since you know that your x is 2, right? You want the probability exactly to know that like the x, what they found is exactly 2, right? So now you say 2 here, 2 is gonna be your x, right? And then your mean is gonna be your NPO for the first sampling plan, right? And then since you are looking for the probability at exactly 2, right? Your probability of your probability, your cumulative is gonna be false, right? So you're looking for the probability at exactly that point. So the cumulative is gonna be false, right? And then you're gonna close your brackets, right? And then you're gonna press equals to, wait, let me just verify something. Oh, sorry. So here it's NPO1. It's not the sampling plan, right? Your mean is your NPO, right? So you're gonna say this is gonna be your NPO1 for the first sampling plan, right? And then now you're gonna drag, right? So now, after you are done with it, so now let's say if they found 2 in the first sampling, right? So in the second sampling, you have to find 3 or less, right? So now you say equals to, right? And then you're gonna say Poisson, so still gonna use the Poisson distribution, right? So when I say now, you know that they found 3, right? So X is gonna be 3 or less, right? And then you mean this this is for the second sampling, right? So which means you're gonna consider the NPO for the second sampling, right? And then now, like your cumulative, right? Since they are looking for the probability at 3 or less, right? So something or less, right? Which means you're looking for cumulative probability, right? So you're gonna use true, right? And then equals to, and then we will drag. So now, after we have dragged, so now after we've dragged, calculate like now what would happen if they found 3 defectives, right? So let me just double check something. I'm just double checking something. Okay, so now moving on to the other plan. Let's say they found 3 right now. So you say poison test, right? So probability of 3, right? And then you cumulate it. So since this is the first sample, your NPO that you want to consider is going to be for the first sampling plan, right? So we're going to say this. And then since you're looking for a probability at exactly that point, you're going to look a probability. So you're not going to look for cumulative probability. So your cumulative is not going to be true. Instead, it's going to be false, right? And then when I close your bracket, right? And then now you will drag, right? And then now you want to calculate the probability of the second sampling if they find 2 or less, right? Which is also going to be given by the Poisson distribution, right? So similarly to how this works, right? So say Poisson distribution for them, if they find 2, right? And then your NPO, since this is their first sample, you're going to consider this NPO, right? And then your cumulative, since you're looking for the probability of 2 or less, your cumulative is going to be true, right? And then equals to, and then now you drag, right? So now after you are done with that, so now you calculate your probability of acceptance for the double sampling plan, right? Which means now you calculate your probability and percentage of acceptance for a double sampling plan. So now probability of acceptance for the double sampling plan. And then you can also now say your percentage. So I'm just gonna copy this. Then I'm gonna change this to percentage. So now you can calculate both these values, right? So now, as I said, so this is gonna be your PA for 2 probability of acceptance for a double sampling plan, right? And then this is gonna be your percentage of acceptance for your double sampling plan, right? And then now, and then now, to get the probability of acceptance for a double sampling plan, as I indicated in the formula. So it's the probability of that they find two, exactly two, which means in the second sampling they have to find, so like this, I, they have to find three or less, right? So if you look at the linear guide, like this formula is explained like more in detail, right? And then you multiply this, so you add and then you multiply this by this, right? And then now you drag your formula, right? Okay. So it seems like there might be something I'm doing wrong. So like give me a chance like to confirm my numbers. Let me just confirm my numbers. Let me just recalculate this. So it will be equals to Poisson's distribution, right? Then we it's gonna be so yeah, I'm still trying to figure out if I'm doing anything wrong. So okay, so I figured out what was wrong with the problem, right? So there was nothing wrong with the formulas, right? So the formulas are all correct, right? What was wrong is that I took the wrong sample number. The sample number for the second plan, it was supposed to be 200, right? So sorry about that, but as long as you fix it, right? So now if you fix it, as you can see, everything now adjusts to become correct, right? So now as I'll say, calculate your percentage of acceptance plan by doing the so it's this multiplied by this plus this multiplied by this, right? So you can get the percentage of acceptance, right? As I explained earlier, where does this formula come from, right? So now you calculate, now after you are done with that, you calculate your percentage of acceptance for the double sampling plan, right? Which is equals to this multiplied by 100, right? And then now you drag, right? And then now after you are done with that, you have to calculate your combined probability of acceptance, right? So now calculate your probability of acceptance factoring in both the sampling plans, right? And you also calculate the percentage. So now calculate the combined probability of acceptance. So this combined probability of acceptance, like it factors both the sampling plans, right? So now just say copy this and then so combined. This is the percentage side, right? So we calculate the percentage of acceptance, right? So now calculate the combined probability of acceptance by simply adding both of the sampling plans, right? So I'm just going to name this P combined, right? Which is going to be given by equals to the sum of this, right? So this is the probability of acceptance for the first sampling plan plus the probability of acceptance for the second sampling plan, right? And then this is the combined probability of acceptance, right? And then now you can drag this, right? And then now for you to get the percentage, combined percentage of acceptance, you just it's 100% P combined, right? Which you get by multiplying this by 100, right? And then you drag, right? So now since you are done, right? Now you can determine your probability of acceptance, right? So now, like now, since you see, so now you see, right? Depending on now they can ask you, right? So now what's the probability of acceptance given that they can I put this? Given that they found like two defectives on the first sampling plan, right? So now to get that probability of acceptance, like given that they found two defectives on the first sampling plan, right? So now you look for if C here was 2, right? The probability of acceptance it's 34%, right? But if they found 3, probability of acceptance goes down, right? But now, as it stands, now you can determine your probability of acceptance if C is equals to 1, right? As 85% if they use the double sampling plan, which dramatically increases like from the 55% that was initially for like or initially determined by the first sampling plan, right? And then after we're done, we plot our OC curve, right? So we factor in 100 PO, right? And the probability of acceptance for the first sampling plan, the probability of acceptance for the second sampling plan, right? And then we go to insert recommended charts, and then we go to all charts, then we go to scatter plot, and then we select this one, right? And then now, do I select this one? No, so now this is our OC curve, right? So now if I can make this bigger, it's too big. Now I want us to justify our axis, right? So under maximum here, so our maximum is 120, we're gonna reduce it back to 100, right? And then here our x-axis is, so let me just so let me just yeah. So now you just click on your x-axis, right? And then now since your graph ends at 10, you reduce it back to 10, right? And then you have your smooth OC curve, right? So now you can label this as OC curve for a double sampling plane. And then now you can label your axis, your x and y axis, right? So this is gonna be given by proportion or percentage non-conforming. Which is gonna be your 100 PO, right? And then it's gonna be your percentage of acceptance. Right. So now you have your OC curve, right? So this is how you sketch your OC curve using Excel, right? So thank you guys for watching. Wait, before I close, right? I recommend it's also advisable like to go over the guide that I compiled for you. Like it explains some of the things that I might have missed in more detail, right? So yeah.